Hi there. So I picked up this very inexpensive amplifier board. It's another TPA, what is it, 3116 D2. It's a very inexpensive digital amplifier, which means Class D. And this is very much like the knob sound one I had a review on my channel a few videos ago, also known as the Breeze Audio. Anyways, those are pretty good. They've been reviewed by others on the internet, and I like my knob sound one quite a bit. In fact, I ordered another, I think a Breeze sound off eBay, much cheaper than I paid for the knob sound, which I think I spent $40 on. I think the one I got off eBay that's coming is $27. This one is very inexpensive as well. Here's the board I bought off eBay. So you can see I paid $14.89 for it. Interesting is on the picture here, it shows slightly different capacitors for the output filter than I got. I have these yellow ones, but I looked these up, and what were these? 0.68 microfarad or something like that. Anyways, I'm sure it's equivalent. Seller name, where's the seller name? Brand, item description, oh look at that. Item description. Maximum output power, 50 watts a channel into 4 ohms. I don't think so. A little under 15 bucks. I didn't intend to put this in a case. I was just going to use this on my bench. Oh, and here's the seller's name right here. World Sky 2013. So it's quite interesting. The heatsink is actually a decent size on this one. As you can see, it's not bad. It's a lot bigger than the one on the knob sound or the Breeze Audio. So that's nice. It comes with this knob on here, and I think this is one of the relatively cheap potentiometers. And hilarious is this isn't even mounted correctly. You look at where it looks like it's turned up the volume, but it's actually turned off. So as you can hear, it has a D10s for the power. It feels okay, the actual movement. Not too bad. Here is a headphone jack. This is basically a line input, and there's also a line input here, and they're actually just connected together directly. So there's that input capacitance. There's the heatsink. These are the capacitors for the input voltage filtering. 1000 microfarad, 35 volts, GSK brand. The inductors, output caps. This is the output filter assembly for essentially when you have these Class D amplifiers, they run at a very high pulse width modulation frequency, and you have to filter that out before you send it to your speakers. You have the speaker outputs, and you have power. And that's basically it. And there's the standoff, holes for the standoffs. That's nice. And then the construction quality looks quite nice. All the soldering looks pretty good. There's no excess in flux. I mean, obviously this capacitor is a little bit crooked, but overall I'm pretty pleased by that. Now, interesting is on the back. Oh, well, one of the things also it was important to me is that the heatsink could be removed. So that's nice. Now, interesting is look at all this Chinese writing here. And here it's talking about PBTL, which usually means something to do with power bridge or running in mono. And I did some Googling, and you see it has S1 and S2 through 6. And you can see these little pads here. There's S5, there's S6. Essentially, what this is saying is, I think right now S1, this one currently has a solder blob on it, but none of the other ones do. And what I read online is that if you remove this solder blob, but then you blob all the other ones, so you remove S1 and then you blob S2 through 6, you actually end up with this amplifier running in bridged mono mode. So if you look at the data sheet for this TPA3116, you can see how to connect it to the output, hook your speakers up, and I don't remember exactly what it is, but you'll get a bridged mono output. So that's pretty nice that that's available right here on the board. Other interesting things here is it looks like the gain is also configurable via a blob. So I'm going to test that. I'm assuming a check mark means blob is there, and that's 26 dB gain, and no blob is 32. So I would assume this is 32. I haven't powered this up yet, so I haven't tried it. There's also a blob here for PSW, or I assume power switch, and V2 and V1, which I'm assuming is volume 1 and 2, maybe for right and left. And I think looking at the traces, I think what that means is if you remove this potentiometer completely and you put a blob there, that just keeps this powered up all the time. And then I think if the potentiometer is removed and you have V2 and V2 and V1 blobbed, that means that it just runs at full volume, because obviously normally removing the potentiometer will result in no sound. It also looks like it's possible to install a voltage regulator here. I assume it's telling us a 78M XX series. So it looks like a surface mount one. There's the two pads for the pins, and then this is the back of the component. And I think what that does is you end up with a V out. So what is that? A 5-volt regulator, and then it ends up with 5 volts, or maybe that's 3.3. And I think the purpose of this is perhaps if you want to run a Bluetooth module directly off of this board without needing to, you know, power it up separately. Because of course, if you're going to put 12 or 24 volts into this, you're going to need a voltage regulator to run any kind of Bluetooth module. So I think that's what that is. There's also a mute pin, and I assume what happens is you blob that, and then you can use the mute pin, which you can probably hold high or low. I don't remember what the data sheet says, to mute the output. And on the other side is one that's labeled SD, which I'm assuming means shutdown. So this is a way to shut down the entire chip as well. So instead of using the physical power switch like this, you can actually use the shutdown here to do it as well. It's sort of like a soft power off. The chip is still running. Well, it still has power, but it's in a completely low power state. So that's kind of cool. So those things are available to you for projects. These two pins here, it looks like there is a power LED there, but if you want to actually connect an LED yourself, and you know, one that you can expose through a case, you can do that as well. So I have to say, from a feature-wise, functionality-wise, I mean, this is a pretty good board. I'm very impressed. Now, hopefully it sounds alright. By the way, there's this here, SM, which I think it's something to do with the manufacturer, of course, TPA3116 Amp, and then update, 2016, what is it, February 18th. So relatively new. And 24 volts input, which of course, like I said, these caps here are rated for 35 volts, so if you put 24 volts into this, that's plenty of safety, plenty of headroom. Not bad. So let's give this a try. Okay, so I have the board connected to 24 volts. It's currently off. Let's turn it on. Kind of an annoying blue LED there. But anyways, as you can see on the power supply, it's using about 54 milliamps at 24 volts. That's the idle power. So that's not too bad. I'm going to hook it up to something. We're going to see how it sounds. Okay, well the amp is connected to my speakers and my bench power supply, which you can probably hear using 53 milliamps, and I have it plugged into my computer here. Okay, one thing I find is the volume knob is very sensitive. You hardly turn it at all, and the volume is coming up very quickly. Okay, so the gain is obviously set very high. Actually, interestingly enough, if I take the input out here, you won't be able to hear it on the camera, but it's pretty hissy, and it's quiet now. So I don't know how this potentiometer is, you know, modulating the input, but right now I don't really hear any hiss. But as I turn this up, wow, lots of hiss. I mean, not a horrible amount, but it's certainly not exactly quiet either. So that's kind of lame. I don't think the knob sound one, which is right here, the knob sound, I don't think this has a similar hiss behavior, even though it's using the same exact chip. So clearly the circuit design is not as good. But yeah, that's a lot of hiss. But if I plug this back in here, I mean, I barely turned it, and that's pretty loud. I mean, a comfortable listening level that if I'm working in the background, just barely turned from the bass. In fact, oh, I just realized I need to turn up the power output. Give it 2 amps there. Let's turn this up a little bit. Does sound pretty good. Sounds a little bit bass heavy, but you know, I'm not sure compared to that knob sound. But definitely you can hear the hiss even while listening to the music. When I had it turned up loud there, I could hear the hiss over the music. So that's really objectionable. So I don't know how much I really like this amp, I have to say. Okay, so I just took the heatsink off, and hey, it was actually pretty nice. It included 2 washers and the screws, and actually had some heatsink compound on there. The nice thing is with the washers, even when the screws are tightly screwed down, it's not actually putting a lot of stress on the chip. I mean, it looks, you can tell it's obviously was being pushed quite flat there. But on the knob sound ones, when you tighten the screws down, it actually kind of bends the circuit board a little bit because they don't bother with the washers. There it is. So I'm going to try to figure out how the gain is configured, and I'll see what I can do about that. Definitely, when you short these pins together, it reduces the gain down to, I guess, 26 decibels from the 32. It's a measurable improvement in the ridiculously oversensitive volume. I touched my multimeter probes to that, and I registered about 28 microamps going through those pads. So I'm going to put a blob on there. Well, there's the amp. I have it on little nylon feet, and I kept the Lee-Pi silver plastic knob on it. I don't know, it looks cheap, but it's a bit bigger of a target than the little black one that was on there. I might do something like mount this on my wooden shelf here. I don't know, do something with it, or like I said, maybe I'll find a case for it, although it's fine the way it is. And yeah, I'm pretty happy with it. With that 26 decibels of gain, the hiss problem was reduced quite dramatically. It still has a little bit of hiss, but you know, I'm sitting just a couple feet from the speaker, so it's pretty clear. But when you turn the volume up quite loud with the 26 gain, it's you know, the music is really loud. So yeah, you can hear the hiss, but it's not too bad. And the computer that I have it plugged into doesn't have a very clean output, so it's a bit hissy as well. But even with nothing plugged into the input jack, it still hisses. But anyways, not a bad amp for 14 bucks or 15, and because it's based on the usual TPA3116 architecture, you can pretty much be sure that with a 24 volt power supply and enough current, it's going to give you some decent output power. And the real reason why I got this was to replace the Lee-Pi, which, you know, sometimes down at my bench here, I do like to crank the music if a song comes on that I really like, and I knew that the older amp was clipping. So with this amp and a 24 volt power supply, I think I'm using a 20 volt power supply from a laptop, then you know, I have a lot more headroom. So I'm pleased. $14. It's really not too expensive. Although now I think about it, I probably should have just got the Breeze Audio one, which was $27, and done the 20 decibel gain mod that I did in my other video by removing that resistor, and I'd probably be happier. It has a nice aluminum case, and of course, it doesn't really have any hiss, so it works nice. Plus it has a power switch, and this one you gotta turn the knob. That's just stupid. So there we go. Thanks for watching. Hopefully you found this interesting. Bye-bye.